Good evening, and thank you for braving a cold and windy fall night to join us for this timely opportunity to host a community forum with an expert in the field of virology and vaccines as we slowly emerge from this long pandemic season. I'm Agnes Norfleet, the senior pastor here at Bryn Mawr Presbyterian Church, and I welcome all of you who are with us here in the sanctuary, as well as we know many people are joining us on our live stream online. We are glad that you are here. These community forums were established by a gift from Anna and Herbert Middleton to the Bryn Mawr Presbyterian Church Foundation. We're grateful for their memory, which lives on through their generosity and commitment to this church. These forums are intended to serve as an outreach to the larger community by welcoming distinguished speakers to share their expertise on matters pertaining to the public welfare and the common good. This church has a long tradition of opening our doors to the wider community for many and various events related to mission, interfaith dialogue, matters of social justice, and special musical and artistic offerings. Before we begin our program tonight, know that our next forum will be this spring on Monday, March 27th, to hear from Dr. Eddie Glaude, Jr., the Chair of African American Studies at Princeton University. Before I turn the introduction of our guest over to a member of our Community Forum Committee, Dr. Rich Allman, know that after Dr. Offit's presentation, there will be a time for questions and answers from microphones made available by a couple of our Community Forum Committee members to those of you who want to ask a question. And then following the time of Q&A, there will be a book signing in our atrium, which you can find by exiting the sanctuary and turning to the right. We're grateful to Dr. Rich Allman for helping secure this invitation and for introducing you to Dr. Paul Offit.
Thank you, Agnes, and good evening. On behalf of the Community Forum Committee, we're honored to welcome Dr. Paul Offit as this evening's speaker. Dr. Offit is a native of Baltimore. He attended medical school at the University of Maryland and was a resident in pediatrics at the Children's Hospital of Pittsburgh. He was a fellow in pediatric infectious diseases at Children's Hospital of Philadelphia, where he has spent most of his professional career. He is currently the director of the Vaccine Education Center at the Children's Hospital, the Morris R. Hilleman Professor of Vaccinology and Professor of Pediatrics at the Perelman School of Medicine at the University of Pennsylvania. Dr. Offit has had a prolific career as a clinical scientist and educator. He's authored more than 160 scientific articles and 10 books. His contributions to the science of vaccine development have been monumental, including the Rotavirus Vaccine for infants. He's the recipient of numerous rewards for outstanding scientific achievements in teaching locally, nationally, and internationally, and he has served on numerous professional advisory panels. Triple threats in medicine are rare: those who achieve excellence in patient care, education, and clinical science research. Dr. Offit qualifies as an even rarer quadruple threat, also having made important contributions to educating the public about infectious diseases, prevention, and zealously dispelling misinformation about vaccines and healthcare in the public sphere. In this latter endeavor, he combined scientific rigor and integrity, clarity, and a measure of humor. His ongoing commitment to public health and disease prevention has drawn him to an active role in the recent and current health crisis associated with COVID-19. Please welcome Dr. Paul Offit to our podium.
So thank you very much for that kind introduction. I can say without fear of contradiction, I never imagined in my life I would be standing here. So my plan tonight is to go through kind of where we were with this pandemic, where we are now, and where I imagine we're heading. So I'll start from the beginning. At the end of 2019, in October, November, a bat coronavirus made its debut in the human population in Wuhan, China, where it killed initially dozens of people before it left. It took about 3 months to isolate that virus and then to determine the sequence of its genes. So the genes, or in this case it's a so-called single-stranded RNA virus, that piece of genetic material teaches the virus how to reproduce itself. So it only took 3 months to isolate the virus and then to determine its sequence. This enabled researchers to make a vaccine. Now that original strain, the strain that first made its debut in Wuhan, was called the Wuhan 1 strain. That is the strain to which all vaccines are made, whether it's Pfizer's mRNA vaccine, Moderna's mRNA vaccine, Johnson & Johnson's vectored virus vaccine, or the Novavax purified protein vaccine. All the vaccines that you have received to date have been designed to prevent that virus, Wuhan 1. Now, that's not the virus that left China. The virus that left China had one base pair change. So the SARS-CoV-2 spike protein, which is the protein that allows the virus to attach to cells, it's a protein, so it's made up of amino acids. In the case of the spike protein, about 1,270 amino acids. Right in the middle of that molecule, at amino acid 614, there was one base pair change. One. That allowed the virus to become much more stable, and it allowed it to be 10 times more contagious. That's the virus that left China, not Wuhan 1. And that's the virus that swept across Asia, swept across Europe, swept across the United States, and killed hundreds of thousands of people. It then took 11 months, really from the initial isolation of that virus, to make vaccines. That is remarkably fast. I was fortunate enough to be part of a team at Children's Hospital of Philadelphia that created the Rotavirus Vaccine, Rototec. That was a 26-year effort. That's about average for how long it takes to make a vaccine. The reason this was so fast was the Trump administration's Operation Warp Speed. What they did was something that has never been done. Well, you could argue that actually the polio vaccine was sort of Operation Warp Speed 1. This was Operation Warp Speed 2, where what the government did was they put a little over $11 billion into the effort and took the risk out of it for pharmaceutical companies. Basically, they said, we'll pay you to do the research, we'll pay you to do the big experiment to see whether or not the vaccine works and is safe, we'll pay you to build the building, we'll mass produce the vaccine, and if the vaccine doesn't work or isn't safe, we'll throw it away. We'll throw away hundreds of millions of doses. No company would ever do that. And so that's what allowed that to happen so quickly. Previously, the fastest vaccine ever made before this vaccine was the Mumps Vaccine, made by Maurice Hilleman here in Philadelphia, which took about 4 years from the isolation of the virus to the production of the vaccine. So this was the fastest vaccine ever made. And the studies that were done, that were then presented to the FDA's Vaccine Advisory Committee, on which I sit, were presented on December 2020. December 10th, December 17th, 2020. We heard Pfizer's presentation and we heard Moderna's presentation. Those two trials were respectively 40,000 people and 30,000 people. So, and half got the vaccine, half got placebo. That's the size of any typical pediatric or adult vaccine trial. And the safety follow-up, at least to see whether there was any immediate problem, were typical, about 2 months after the last dose. When those data were presented to us, they were remarkable. I mean, Dr. Fauci and others at the FDA had said that we would approve this vaccine if it was 50% effective. As we got closer and closer to the end of the trials, Dr. Fauci predicted this vaccine could be as effective as 70% effective. But in fact, both vaccines were 95% effective. Not only were they 95% effective, they were 95% effective against not just severe disease, but mild or moderate disease. That was a remarkable result. And so, for that reason, they were then approved, December 2020. So how well did they work? I mean, they were made to prevent Wuhan 1. But again, the vaccine that left China was not Wuhan 1. It didn't have a Greek letter designation. It was called this D614G. And then that was replaced by the Alpha variant because it was more contagious, which was replaced by the Delta variant because it was more contagious. And that sort of takes you through 2021. So how did we do? How did that vaccine do? That vaccine that was introduced in December of 2020. So let's look 6 months later. 6 months later, studies were done to answer the question, if you'd received 2 doses of that vaccine, did it protect you against serious disease? And the answer was uniformly yes. There was study after study after study that showed if you got 2 doses of the vaccine to protect you against Wuhan 1, you were protected against severe disease. But you weren't as well protected against mild disease. Protection against mild disease dropped to 50%. So why? Okay, so now I'm going to give you a little immunology here. Hang in there. If I don't explain this well, it's my fault, and just make sure that you ask questions so that I clarify it. When you're trying to protect yourself against a virus, there are really 2 components of the immune system that are responsible for protection. One, the one that you read about most of the time, are virus neutralizing antibodies. So when you're naturally infected or when you're vaccinated, you will make virus-specific neutralizing antibodies. And what those antibodies do is they prevent the virus from attaching to cells. The good news is they work well to protect against a virus attaching to cells. The bad news is neutralizing antibodies are always short-lived. Always. There's no way around that. Neutralizing antibodies over time will fade. And so because neutralizing antibodies are responsible for protection against mild disease, and because neutralizing antibodies typically fade 6 months later, protection against mild illness dropped. So you could reasonably ask the question, why were those trials so good? Why did those trials show 95% protection against mild disease? And the answer is those trials were done over a fairly short period of time. They were done over about 3 months. So most of the participants in that trial, or in those trials, had recently received their second dose. So they still had high levels of neutralizing antibodies. So why does protection against serious illness hold up where protection against mild disease doesn't? And that's because protection against serious illness is not mediated by neutralizing antibodies as much as it's mediated by another component of the immune system called T cells. So there's 2 different kinds of T cells. There's the kind of T cells called helper T cells, which help your body make antibodies. B cells make antibodies. And then there's another kind, and this is the really important one, called cytotoxic T cells. What cytotoxic T cells do is they kill virus-infected cells. The good news, there's 2 good pieces of good news about cytotoxic T cells. One, they're long-lived, years, sometimes decades. And 2, they don't recognize the part of the virus that changes so much. And we'll get to Omicron in a second, but they recognize conserved regions. So the regions that are recognized by these T cells that are long-lived and protect against severe disease are really not much difference between Wuhan 1 and the current strains that are circulating. That's why if you've been immunized against Wuhan 1, which is what we all have been, I hope we all have been, but we should have all been immunized against Wuhan 1, you're still protected against serious disease. I'll use myself as an example. So I got a dose of vaccine in December when it first came out, December 2020. I got another dose in January 2021. And then I got my 3rd dose in May of 2021. 3 doses. 1 year later, May of this year, I had a mild infection. Mild. Now I'm older, as you can see, because you can see me standing here. But so if I had 3 doses of a vaccine directed against Wuhan 1, but I was protected in May of this year when probably I was infected with an Omicron subvariant called BA2 because of those T cells, because of those so-called cytotoxic T cells, which are long-lived and which recognize parts of the virus that are conserved across all these strains, at least to date. Okay, hopefully that made sense. So where were we at the end of the first year? So now the vaccine comes out in December 2020. Where are we in December 2021? Where are we about, 9-10 months ago. So again, the CDC did a series of studies trying to answer the question, were you still protected against serious disease? Because remember, that's the goal. It's the only achievable goal. It's the only reasonable goal. Because neutralizing antibodies are short-lived, you are going to be at risk for mild illness for as long as this virus circulates, which I think is going to be a very long time. Certainly years, if not decades, if not longer. So were you still protected against serious disease at the end of the first year that vaccine came out? December 21, right? Vaccine comes out in December 2020. Where are you 1 year later? So the CDC did a series of studies to answer the question, were you still protected? And the answer was yes, you were still protected against severe disease. You were still protected if you were over 65. You were still protected if you had the kind of health problems that put you at risk of serious disease. You were still protected independent of whether you got the Pfizer vaccine or the Moderna vaccine. You were still protected 1 year later. That's good. Then things changed. And what changed at the end of December, beginning of January of this year, was Omicron. So Omicron was a variant that I think no one would have predicted. It was a highly mutated strain of this virus. More along the lines of influenza. I don't think anybody really imagined that coronaviruses could act like influenza virus, but this virus did. So even if you were naturally infected or vaccinated, or recently naturally infected or vaccinated, because this virus had mutated so far away from recognition by neutralizing antibodies that you still were at risk now you're at risk for mild disease, even if you've been vaccinated or naturally infected. So then what happened was the CDC did a series of studies trying to answer the question, was more better? Did you benefit from a third dose, or did you benefit from a fourth dose? So these were the studies that were done really in the first 6 to 8 months of this year. And what they found was that for people who got a third dose of vaccine, that they were clearly less likely to be hospitalized than those who had only gotten 2 doses. So this was the birth of the third dose recommendation. They also found to a lesser extent that those who received the fourth dose had a lesser risk of hospitalization because remember, the goal is preventing hospitalization. The goal is preventing keeping people out of the hospital, keeping them out of the intensive care unit, and keeping them out of the morgue. That's the goal of this vaccine. And what they found was that there was an advantage to getting a third or fourth dose. But the question was, who did it benefit? Did it benefit everybody, or did it benefit just certain high-risk groups? And the answer was, according to the CDC criteria and publications, it really benefited, for the most part, high-risk groups. So those high-risk groups include I'm trying to think of a nice way to say this as I get older, the elderly, okay? I said it. But it was really, as Dr. Walensky says, who's the director of the CDC, she uses the term elderly, which means people over 75. God bless her, I'm not there yet. So really, that's how she defines elderly. And so people who were over 75, people who lived in long-term care facilities clearly benefited from getting a third and fourth dose. It was also true for people who had certain medical conditions that put them at high risk of serious disease, like serious lung disease, heart disease, type 1 diabetes that was out of control. Because for those people, because they were frail enough from their underlying illness, for those people, even a mild illness could land them in the hospital. So they benefited. And then the third group were people who were immune compromised. Those were the 3 groups, according to CDC criteria, that most benefited. So when the CDC makes its current recommendation on September 1st, that everyone over 12 years of age is recommended to receive this vaccine, this new bivalent vaccine, you could argue that the better recommendation would be to target those who are at highest risk. Okay, so where are we now? Clearly, we have much higher level of population immunity. I mean, think about where we were in 2020. We had a blank slate of a population. No one was immune to this virus. We didn't have monoclonal antibodies. We didn't have antiviral medicines like Paxlovid, and we didn't have vaccines. All we had was barrier protection, which is to say mask, social distance, isolate, quarantine, close schools, close businesses, restrict travel. That was 2020. It was just a terrible time. I mean, we had a virus where we had essentially no population immunity. We didn't have vaccines. We didn't have monoclonals. We didn't have antivirals. All we could do was try and limit human contact. And we did a pretty good job of it. I mean, I can tell you at Children's Hospital of Philadelphia, here's what we didn't see, even though we were obviously overwhelmed with COVID patients. I mean, overwhelmed to the point we couldn't do elective surgeries. What we didn't see was flu. Usually we see flu every year. Typically, influenza kills 75 to 150 children every year in this country. In 2020, it killed one child. We didn't see a virus called respiratory syncytial virus, which was a common cause of a lung disease called bronchiolitis, gone. I mean, that's how effective that was. I mean, obviously, it's not a viable strategy moving forward, but that's how effective that strategy was, which tells you it would have been much worse had we not done that. Okay, so now we have those things. Not only do we have monoclonals and Paxlovid, we have vaccines and a variety of vaccines. The other thing we have is population immunity. I mean, right now, if you look at sort of studies where they look at the percentage of people who donate blood to see whether they have antibodies, you probably have 95% of this population that has either been vaccinated or naturally infected or both. So that's why it is that you've seen a dramatic reduction in hospitalizations and a dramatic reduction in deaths. I know it may not feel that way, but think back to 2 years ago when you would have 3,000 people die a day, 3,500 people die a day, 4,000 people die a day. We are not there at all anymore because we are a much more protected population from natural infection or vaccination or both. So it seems to me that the following things are true. There are 4 strains of human coronavirus that circulate in the population. They account for 15 to 20% of the respiratory viruses that come into our hospital every winter. The first 2 were isolated in the early 1960s. They too both came from bat viruses that entered the human population. So the question is, when did they enter the human population? Studies by Susan Weiss at University of Pennsylvania and others showed that one of them entered the human population in the late 1700s. The other one entered the human population in the late 1800s. I think it is fair to assume this virus is going to be with us for a long time, at least years, probably decades, and possibly longer. So this virus will continue to circulate. Even if you've been naturally infected or vaccinated, the virus will continue to circulate. Even if 100% of people in this world were vaccinated and the virus never mutated, never created variants, it would still circulate. The goal, because it is a short incubation period disease. And when you have a short incubation period, those memory cells that I talked about don't help you for preventing mild illness because it's too fast. Memory cells like memory T cells or memory B cells, which make antibodies, T cells like cytotoxic T cells, they exist in your body for a long period of time. But in order for them to become activated and then differentiate to become cells that help, for example, kill virus-infected cells, that takes time. And if you look at Omicron, which has an incubation period of about 3 days, incubation period means from the time when you're exposed to when you develop symptoms, 3 days is too quick for those memory cells to become activated and effective. It's too fast. So because neutralizing antibodies fade, therefore we're always at risk of having this virus circulate and cause mild illness. That's not true for long incubation period diseases. For long incubation period diseases, there's plenty of time for those memory cells to become activated and effective to even prevent mild disease. There's plenty of time to essentially create sterilizing immunity. And that's what happens. Take a long incubation period disease like smallpox. You can eliminate that kind of virus from the face of the earth, and we did. Take a long incubation period like virus like measles. You can eliminate that virus, which we did from this country by the year 2000. The problem is it's come back in some small part because a critical percentage of parents have chosen not to vaccinate their children. Take a long incubation period virus like rubella or German measles, which was a common cause of congenital birth defects, primarily when women were infected in the first trimester. We eliminated that virus from this country by the year 2000 because it's a long incubation period virus. This is not a long incubation period virus. It's never going to be a long incubation period virus, and therefore it will continue to circulate. I'll give you a more personal example. I was part of a team at Children's Hospital Philadelphia that created the rotavirus vaccine. The rotaviruses are also a short incubation period virus. It's an intestinal virus. Before that virus, before there was a vaccine, and our vaccine was introduced in 2006, before that vaccine was available, every year about 75,000 children would be hospitalized in this country and 60 would die. It accounted for about 500,000 deaths a year in the world, about 2,000 deaths a day. It's a bad virus. I mean, it causes fever, vomiting, diarrhea, and dehydration. With that vaccine, we have virtually eliminated hospitalizations in this country. Most residents in our hospital have never seen a case of rotavirus because of that vaccine, which has been out now for about 16 years. But that virus still circulates in the community, still causes mild disease in the community. If we did PCR testing, to see whether or not there were cases in the community, there are thousands of cases in the community. We don't. We just look at hospitalizations. And frankly, I think that would be a reasonable thing to do for this virus. Focus on what you're trying to do, because you're always going to have cases. And I think we tend to scare ourselves at some level by constantly focusing on those cases and knowing that it's always going to be at some level a problem. So I think moving forward, there are people who, for the reasons I said before, either because of age or the kind of health conditions that put them at risk, or because they're immune compromised, I think will likely benefit from a yearly vaccine. Because this virus still at its heart, although it can circulate all year, is still at its heart a winter virus. So getting that kind of vaccine in a manner similar to the flu vaccine does make sense. But I think for the rest of us, what needs to happen is you need to have two groups collaborating to answer this question. One is the CDC. Who is it? Healthy young people less than 65 years of age who say have gotten 3 doses of the vaccine. For how long are they protected against serious illness? And then that work should be done in collaboration with academic immunologists who then look in your blood and see, do you still have those levels of T cells that predict protection against serious disease? How long are we protected against serious disease? Because this isn't flu. It's not. And I think the notion of a yearly flu vaccine for everybody doesn't necessarily make a lot of sense. And I know that now the CDC has recommended this bivalent vaccine where you get both the ancestral strain, the Wuhan strain, with now BA4, BA5. And if you look at those data, it makes sense. BA4, BA5 is the strain that's circulating right now. That's the predominant strain. So sure, right, makes sense to give that. But if you look at the data in terms of protection against severe disease, you can't find really any good evidence that this vaccine is any better than the current monovalent vaccine. Now, it's the only vaccine you can get now as a booster, and I think it will be certainly no worse than the monovalent vaccine. I would be surprised if it's much better, and I don't think it'll be any less safe. But again, the good news is that this T cell recognition is still very good against the current circulating strains. This is not flu. If you give a flu vaccine every year, because even if you've been naturally infected or vaccinated the year before, you are still at risk of serious disease. And I'll give you an example. A few years ago on the FDA Vaccine Advisory Committee, we pick the strains every year in March for what becomes a September vaccine, right? It's a 6-month production cycle. We're usually pretty good at figuring out what's about to come into this country. Usually it's the strains that are circulating in Australia who have a season before us, or South America, which have a season before us. And we're usually pretty close, but we weren't a few years ago with one of the strains called H3N2. Missed completely. And there was 0% protection. If flu was more like coronavirus, then if you'd been vaccinated the year before with a different H3N2, that should have been enough to protect you at least against severe disease, but it wasn't. This is not flu. So I do think that if we're going to move forward with a yearly vaccine, I do think we should focus on those who are most likely to benefit, and I think it's an incumbent upon the CDC and academic immunologists to figure out how long otherwise healthy young people need to be boosted, if at all. I mean, I do worry about one thing, which is that this protein that we get, the SARS-CoV-2 spike protein, does mimic a protein on the surface of your heart called alpha-myosin. So when you're naturally infected with COVID, you make an immune response to your own heart. I mean, when we see children who have the so-called multi-system inflammatory disease, 75% of them will have evidence of mild heart muscle damage. If you look at people who are naturally infected and have no symptoms, just asymptomatically infected, mildly infected, and you look at do heart scanning, you find about 2.5% of them have some mild transient evidence of heart muscle damage. And the same thing's true for those who are vaccinated. About 2.5% will have transient, short-lived, self-resolving evidence of inflammation of the heart. Now, this is not the kind of myocarditis that I'm used to, which is myocarditis caused by a virus, where the virus actually reproduces itself and kills cells. This is not that. That's why it appears to be so short-lived and self-resolving. But it is, anytime you give a biological, assume that whenever there's, in anything in medicine, that has an upside can have a downside, and that's true here. So I'm hesitant, actually, especially for boys and young men, for people, say, between, say, 16 and 30 years of age, or 12 and 30 years of age. I think otherwise healthy people do not necessarily need to get this vaccine, knowing that healthy young boys and men are at risk of this transient, short-lived heart problem. So that's kind of my feeling about that. So again, I think, just to summarize, and then I'll take your questions, I do think that this invention of these COVID vaccines is the single greatest scientific achievement in my lifetime. I mean, in my lifetime, it includes the development of the polio vaccine. It was done very quickly and very well. I think the mRNA technology fits very well for this particular pathogen, this particular germ, and I think it has saved our lives. It's the number of people who would have died had they not been vaccinated is much greater. My only regret in all this is that 100% of the population didn't get vaccinated, because it's been hard to watch. I mean, when at Children's Hospital Philadelphia, when a vaccine was available in December 2020, we would see kids come into our hospital in 2021 who weren't vaccinated, who suffered. I mean, who suffered because they struggled to breathe, because their lips were blue, they were given oxygen, they were given continued positive airway pressure, they were brought up to the intensive care unit and put on a ventilator or an oscillator, and about 1,000 children less than 18 years of age have died of this virus. And it's preventable. It's a preventable death. There's just no good reason not to get a vaccine if you haven't gotten one. I mean, when I'm talking about getting booster doses, I'm talking about people who are already vaccinated. I mean, there's no good reason not to be vaccinated. So I'm going to stop right there and then step down to this microphone and take your questions. Thank you.
Once again, thank you, Paul, for a great presentation. We'll have 30 minutes for questions and answers. If you have a question, the ushers have handheld microphones that they will give you. Please keep your questions brief, and please no monologues.
Oh, sorry.
Hi, Dr. Offit. I said to my partner before we drove here, I want to ask Dr. Offit about T cells, so I'm glad you spoke to that. It's two-part. There are millions of people in this country who are immunosuppressed. I'm one of them. I had a lung transplant a year and a half ago. I'm doing well, but the drugs I take, sort of, as far as they can measure with the whole antibody thing, I don't seem to have measurable immunity. But then I've heard about the T cell thing. I've heard you on Dr. Radio many times. It seems like there's some argument or disagreement between you and other scientists about the importance of T cells. I often think to myself, I hope he's right that the T cells matter, because if you're right, then I have some kind of immunity. Could you speak to that?
Yeah, I think T cells matter. I mean, studies by John Werry at the University of Pennsylvania, Shane Crotty at UCal San Diego, sort of non-human primate studies doing sort of elimination experiments clearly show that T cells, especially cytotoxic T cells, matter. The question is whether someone like you has generated T cells. I mean, for the same reason you may not, because you're immune suppressed, you may not be able to generate antibodies against this virus. You also may not be able to generate T cells. So I think what we need to do is, for people like you, and there's probably 9 million people in this country who can't be effectively vaccinated, Do we have any obligation to them? Of course we do. This is a contagious illness. So I think people like you are exactly why it is that we need to get vaccinated, not only to protect us, but to protect people like you. I think we do need the kinds of studies to look at. The term immune compromise is a very broad term. I mean, immune compromise could mean you're getting chemotherapy for your cancer. Immune compromise could mean you're getting a monoclonal antibody for your rheumatoid arthritis. That's a big spectrum. So you need to see in whom you're generating T cells based on their level of immune being compromised, and also what best generates those T cells. I mean, you could argue that so SARS-CoV-2 virus, the virus that causes COVID, has 4 proteins. One of the proteins is called a nucleoprotein, which is probably the protein that's best recognized by cytotoxic T cells. So maybe that should be your one's bivalent vaccine, to get the nucleoprotein. Again, all these studies need to be done. I think the NIH needs to step up to help us answer these questions. So hope that helps. But I do think T cells matter. Whether you generated T cells based on your level of immune suppression, which I don't know, is an important question. But I do think I can reassure you that without any neutralizing antibodies, it's clear that T cells can protect against serious disease. I think there's a lot of non-human primate studies that have shown just that. So I think you can take some solace in that. Okay, better. Okay. Could you do me a favor? Could somebody take a picture of this? I just have got to show my mother this. Have you got a picture of this? Good. I have got to show my mother this.
Dr. Offit, thank you very much for your presentation tonight. I did want to ask about why natural immunity has been so discounted from the beginning, especially with the T cell response that we were talking about, especially from some of the earlier studies from the Cleveland Clinic on the medical professionals and the recent study from Qatar showing that even extended protection 97%. So instead of just this vaccine for everybody, because I think some of that that has generated a lot of questions in the public. Thank you.
No, it's a perfectly reasonable question. I mean, certainly we know that if you're naturally infected with measles, you're protected for basically a lifetime. You're naturally infected with mumps, rubella. So why would this virus be any different? I think first of all, I agree with you as a general rule that I think natural infection does likely induce long-lived immunity, certainly T cell immunity, but the nature of the infection does matter. I mean, when people look, for example, at an asymptomatic infection or mildly symptomatic, to some extent, especially asymptomatic, was not as good at generating, say, high frequencies of memory B and T cells as was a more significant infection. So the thinking at the time was, all right, well then let's just sort of cover our bets and give a vaccine in someone who's been naturally infected because we don't know that. But I do think, I actually support your point of view. When we mandated vaccines, for example, and people could come and say, look, I've been naturally infected. Here's antibodies against nucleoprotein in my bloodstream that could only happen if I was naturally infected. I don't think I should have to get a vaccine. I think that actually was perfectly reasonable. If it makes you feel any better, there was a meeting between Dr. Walensky, Dr. Fauci, Dr. Murthy, so Dr. Walensky is the head of the CDC. Dr. Fauci is a name I'm sure you all know. Dr. Collins, when he was still head of the National Institutes of Health, and Vivek Murthy, who was the Surgeon General. They asked actually me and 3 other people, immunology, virology types, to answer that question. Did we think that natural infection should count as essentially being immune, especially in an era of mandates? Because there was a lot of pushback from people about that, and understandably so. And I was actually one of 2 yes votes. I thought they should have counted, but there were 2 no votes there. I'm not going to tell you who the yes and no votes were, but I actually agree with you. I think the reason that the vaccines were given was primarily as a belt and suspenders approach. But what you're arguing is reasonable.
Hi, Dr. Offit. My understanding is that there is a theoretical risk that if you are immunized against the same strain of the vaccine over and over again, you could potentially develop a very strong immune response to the ancestral Wuhan variant. But were there to be a more virulent version of COVID in the future, you might have a somewhat suppressed response to that new variant. Is that something that you think is possible?
No, these are very good questions. It's like speaking to a group of immunology, virology types. Yes. There's a term that was introduced in the 1950s by Thomas Francis, who I imagine was Catholic, given this term, original antigenic sin. That's the term. And the thinking is that as you get if you're exposed to a particular immune response or virus again and again, that you sort of link into that, you sort of hook into that. I'll give you an example. I'll give you a more easy to understand example. The human papillomavirus vaccine was introduced in this country in 2008. 2006. It was 2006. In any case, when it was introduced, Merck made that vaccine. It was initially 4 strains. 4 strains in the HPV vaccine. That was replaced by a 9-strain vaccine. So HPV-4 became HPV-9. Today, if you get 2 or 3 doses of HPV-9 based on your age, you develop an excellent immune response to all 9 serotypes. If you got HPV-4 first and then got HPV-9, you actually make a much better response to those 4 strains you got initially, which are still in that 9-component vaccine, than the additional 5. It's still good enough, but it's definitely less. That's imprinting. That's original antigenic sin. You lock into that response. So your point is a good one. Let's suppose, and hopefully we'll know this, because hopefully we'll have the international surveillance to know this. Let's suppose a strain comes around that is completely resistant to protection against severe disease, even if you've been adequately vaccinated and boosted. Then what? Then we're starting all over again. Then you're starting all over again. And have we locked ourselves in to this response by giving so many boosters in some for who aren't going to benefit as well? I mean, I'm not saying if a parent of a 12-year-old came into my office and said, I want to give my child this bivalent booster, I'm not going to try and talk them out of it. If they want to give it, sure. I'm just saying that I think from a public health standpoint, we really should focus on just those who really benefit. And I do think we do need more studies looking at how can we best induce these T cells over a long period of time. I mean, because we keep talking about neutralizing antibodies, we keep focusing on neutralizing antibodies, and we really need to talk more about T cells for just the reason that you said we do. And at our FDA Vaccine Advisory Committee meetings, I can tell you every time we meet about this vaccine, it just seems like every other week, someone will ask that question, where are the T cell data? And everybody agrees that we need to generate more T cell data. So hopefully that will be what happens as we move forward. We need more answers now than we have. Did that help? Yeah, good.
Question here. China has a different approach, so I wonder, does it have any merit, or are they going to face a big catastrophe? And
how do you define their approach as different?
The quarantine and not an effective vaccine and just shutting down.
Yeah, I wouldn't say it's not an effective vaccine. It's not as effective as one would hope. They're a whole inactivated viral vaccine. Actually, when that vaccine first came out, I thought it would be much better than it was. But it's not a bad vaccine. It's just not as good as some of these mRNA vaccines. I think that trying to control the spread of this virus is just nightmarish. I think at some level, moving forward, we are going to have to understand that mild illness is going to be part of our lives moving forward, much as is true for the rotavirus story. I mean, we have probably 95% of babies getting that vaccine, yet the virus still circulates in the community. And that's a virus that doesn't mutate. So I think we're going to have to get used to the fact that mild illness will be part of this moving forward. And that's hard, because we're coming off a time when we didn't have anything, right? We didn't have monoclonals, we didn't have antivirals, we didn't have anything. And the virus clearly can be a killer. But now we have a high level of population immunity. And I just think, I'll give it as a personal, I'll tell you sort of how I see this. So many people here aren't wearing a mask. I mean, I generally don't wear a mask when I go to a grocery store. I know, I'm sorry this is being taped, but and the reason, here's the reason. I've gotten 3 doses of vaccine and had 1 natural infection. I'm asymptomatic. I think the chances that I am shedding infectious virus is about 0. I do. I don't think anybody is at risk from me. So I'm assuming the risk. By not wearing a mask, I'm assuming the risk. And when I walk into a grocery store, I think there very well may be people who are shedding virus. And I think that's going to be true when I walk into a grocery store for the rest of my life. I do. And so am am I willing to take a risk of having a mild illness? I think I will, as I did in May, I got a mild illness. And I think I may continue to get mild illnesses. So what I need to know from the CDC and from immunologists is, when is that risk greater? When is it that my T cell immunity has faded to the point that I am now at risk of severe disease? That's what I want to know. Because I may need a booster dose too, or I need better yet, a vaccine that boosts my T cell immunity the best. That's what I think we need to see for it. So we still have so many more questions than answers, and I know that's frustrating, but I do think that we are going to have to learn to live with mild illness. I mean, unless we just want to do what China does and just try and not have any human interaction, which is just not feasible. Yeah, you have to let that guy know.
Paul, hi. This is Rich Bella, one of your longtime colleagues from CHOP. First of all, I want to thank you for your extraordinary work. My question is, if you would, or I'd like you to see if you would comment on that entity known as long COVID. And how does one even consider it? I mean, we've all been probably infected over, at some point, and when do we ever consider that may be a possibility in our existence?
Right, so thank you. I'm glad you asked that question. I didn't cover that. So long COVID is real. I think it's more than one thing. I think it is over time we'll learn more and more about long COVID, and I think it will fall into 4 separate categories. I think one category it may be true that in some people the virus continues to reproduce itself, which we need to prove that, and if that's true, then things like antivirals may be of value. I think in another group, you're going to see that for some of these, and we clearly see this, there are these sort of small blood clots that can be distributed throughout the lungs and throughout other organs. That's clearly part of long COVID. And I think for those people, things that help dissolve blood clots may be of value. A third thing, and this is clearly true, this is work out of Icahn University School of Medicine in New York, that for some people they have this kind of hyperdrive immune system, this dysfunctional hyperactive immune system, and that's clearly been defined, and I think for those people immune modulating therapies may be of value. And then I think the fourth group, and this is always harder to talk about, is I think anybody who suffers a chronic or long-term disease will have a psychological component to that illness, and I guess because it's hard to live with any sort of chronic illness, and I think that also has to be addressed with a different kind of therapy. But I think we need to understand long COVID better. I would say this in terms of vaccines. There was a study that just came out of Italy that tried to answer the question, does vaccination prevent long COVID? And what they found was that and again, long COVID is variously defined in different countries and different regions, but what they said was that if you were unvaccinated and you got COVID, your chance of long COVID in this study was like 42%. If you got 1 dose of vaccine, that chance of long COVID went from 42% to 30%. If you got 2 doses of vaccine, that went from 30% to 17%. And then if you got 3 doses, you went from 17% to 16%. So no difference between the 3rd and 4th dose. So you can argue that that initial 2 doses, probably did as good as you're going to do in terms of preventing long COVID. Sometimes people will argue for a booster dose, like a 4th dose, 5th dose to prevent long COVID, but there aren't data to support that. Right now, 2 doses appears to be enough, or as good as you're going to do for that.
Hi, Dr. Offit. I have enjoyed your interviews on Zubin Damani, Dr. Zubin Damani's YouTube show. So thank you for those great interviews. Z-Dog MD. Yes, D-O-G-G. He's just been, I think he's been very helpful for spreading good information about during this pandemic. My question is about colleges. Do you think colleges should continue to mandate booster shots, especially with the increased level of natural infection among healthy young adults, as well as higher population immunity?
No.
Thank you.
Was it me now? Is that it?
I don't think it's fair. Healthy, especially, I have a future son-in-law. In June, he will be my son-in-law, and he goes to Cornell, and they sort of mandated that extra dose. And he's a healthy young man who's likely protected against severe disease. And anybody less than 30 who's a male, could have this transient, increase in heart muscle enzymes because of mild heart muscle damage. And what's going to be the long-term effect of that? I don't know. But I don't like that. I don't like that mandate for that. I think you can argue about whether or not it's reasonable to mandate the vaccines for college entry or school entry, because this is a contagious disease. I mean, it is. When you make a decision to not vaccinate yourself, you are making a decision for other people. And so I think that's reasonable. I think it was reasonable that we mandated a vaccine for our healthcare workers who work around a vulnerable population of hospitalized children, many of whom can't be vaccinated. That's reasonable. But I didn't support the notion of the booster dose for our healthcare workers.
Okay.
Yeah, I'm happy to answer your question, but it's the microphone guy you got to convince.
Hi, I'd just like to ask a question about the Pfizer trial data clearly showed an increase in all-cause mortality in the gene therapy group versus the placebo arm. So, and in Commonwealth nations, there's massive all-cause mortality data coming in. And it seems to be caused by the lipid nanoparticles from the vaccines that have been shown to affect the sperm and female fertility potentially. And also there's a concern that the messenger RNA technology can establish cancers that have been in remission or enhance cancer growth by affecting P120 and cancer suppression enzymes. Can you speak to any of this all-cause mortality situation, the non-specific effects of vaccination and not just the antibodies and T cells?
Yes, so I don't think there's any solid data that shows that. I mean, I think the pregnancy issue or the fertility issue is certainly one that came up very early. I think what scared people about this vaccine is it's a genetic vaccine, meaning you're giving a gene, essentially, the mRNA from this virus. And so I think the minute people hear the word genetic, they think that somehow is going to in any way alter your genes, which isn't possible. Just so this is clear, this is mRNA. I mean, first of all, you have about, every cell of your body has about 200,000 copies of messenger RNA in it. That then goes through a system called the endoplasmic reticulum and converted to a protein. So, and then the messenger RNA breaks down. The messenger RNA cannot enter the nucleus. It doesn't have a nuclear access signal, and nucleus is where the DNA is. Even if it entered, let me finish. Even if it entered, it has to integrate itself into the first of all, it's not DNA, it's RNA. So it would have to be converted to DNA, which requires a so-called reverse transcriptase, which this is not part of this vaccine. And similarly, then it would have to be integrated into the DNA, which requires an enzyme called integrase, which it also doesn't have. I mean, the chance that you have, let me finish, the chance that you have of having that mRNA alter your DNA is the same as you're becoming Spider-Man after you get this vaccine. I mean, it's just not possible. I couldn't hear that. I can't hear you.
So it also concerns the repeat boosters, annual boosters of young and otherwise healthy people. If there is a 2% risk of mostly subclinical transient myocarditis from an antibody reaction to a protein on the heart, if young and otherwise healthy people get boosted every single year, could you theoretically increase the adverse reaction?
No, it's possible. That's why I think we should be careful with any biological that we direct it to those who most benefit. I think it's when the benefit is clear, I think it's reasonable to ask people to take a small risk because that's what medicine is. I mean, there's nothing, when we talk about safety, what we really mean is that the benefits outweigh the risks. I mean, when we make a decision in medicine, we want to put people in the position where they take the lesser risk. That's always true, but there's never no risk. But I think when the benefit isn't clear, then I think it's not fair to ask people to take that risk. You know, one other thing just about the pregnancy that you brought up, when the studies were done on the 40,000, 30,000 people back in December 2020, the question was, the companies, I wish they hadn't done it this way, basically excluded pregnant women from those studies. So which is too bad because pregnant women clearly benefit from this vaccine in the sense that if you are a pregnant woman and you're infected with SARS-CoV-2, you are much more likely to be hospitalized and to die than if you're a woman of the same age who's not pregnant. But nonetheless, there were 36 pregnancies during those studies because, as Jeff Goldblum said in Jurassic Park, life finds a way. So there were 36 pregnancies. 18 were in the vaccine group and 18 were in the placebo group, which tells you that had there been a problem with that, meaning if you were less likely to get pregnant, then there would have been more but more instances of pregnancy in the placebo group. Once the vaccine got out there, and then you could see sort of whether there was any problems in, say, a woman who got pregnant who got the vaccine as compared to a woman who got pregnant who didn't get the vaccine, was there any differences in neonatal outcome or fetal outcome? And the answer was no. So I think the pregnancy thing was wrong. I think it was reasonable. It's reasonable to raise any concern, but these were testable concerns, and so I think that obviated that problem.
Yes, Dr. Offit, you mentioned earlier that, I guess offhandedly, it was a bat coronavirus. And I was just wondering, is this your belief that it came from a natural source? And if that's the case, what evidence is best to support that? I've seen quite a bit of evidence put forward that it was a chimeric man-made virus, but I haven't seen like fundamental evidence that it was coming from a natural source.
You're right. This came from a natural source, just like SARS-1 and MERS came from a natural source. Probably the best evidence is that you can find SARS-CoV-2 proteins that are identical to this virus in bats in Laos. I mean, so there's been a number of studies. Also, the whole notion that it came from the Wuhan virology laboratory. When all the original cases came out of that wet market is not the right term, but in that Wuhan market, in that western part of the market where there were, civets and raccoon dogs, I mean, that's where those original cases were. That's where that virus was identified. And that's across the river. So it would have had to, if it was a lab leak, it had to sort of jump across the river and infect all those initial cases. There's actually a number of other reasons why that have to do with this sort of the fear and cleavage site, et cetera. But I think I don't know if you ever listened to a podcast called This Week in Virology. It's for nerds like me, but I think they recently had Eddie Holmes on, who did a lot of that original work on isolating those original viruses, worked with the Wuhan lab. It goes through all the sort of scientific reasons for why. I don't remember the number, but if you get a chance, This Week in Virology, it's the episode with Eddie Holmes. Listen to that, and if you're still not convinced, call me. Well, it's interesting how it affects many different animals. I mean, there's probably been about 2 or 3 dozen animals that have been found to be infected with this virus. Typically not severely. I mean, even dogs can get this virus, but typically not severely. It's also, if you were going to make a virus that was really targeted to humans, this was a bad graduate student that did that because it's a really sort of ubiquitous kind of infection.
Sure. I just was thinking about the bigger picture here, all the financial end of things. There's been a huge transfer of wealth in since the pandemic. We've got all these new class of multi-billionaires, and the wealth of the working man and the poor has been just hammered. I know you yourself have become a multi-millionaire from your proceeds from the work you've done. And I know that University of Pennsylvania recently made $1 billion, or close to $1 billion, from their development of the lipid coating for this vaccine from Pfizer. And I'm just wondering, I think it would be naive for anybody to think that there isn't some form of corruption going on here. The $1 trillion that's been spent by the government in general, but also the tens of billions of dollars received by these marketing companies that all have, the pharmaceutical companies that all have, I'm getting there. Okay, can I, are you good with that? Can you give me a minute? All right, I'm getting to it. So my question to you is, where do you see corruption influencing science, corruption influencing the pharmaceutical companies? In general, where do you think the biggest problem with that is? And in your own personal experience, where have you seen, conflicts of interest? I know like Senator Rand Paul recently asked Fauci, who's making money on these committees? Who's making money from these pharmaceutical kickbacks, you know? And Fauci wouldn't answer him. They redacted that information.
Thank you.
There's concern that there's a lot of conflict of interest.
Come on. Thank you for your. I'm going to answer your question. Put your finger down and I'll answer your question. Since you've chosen to attack me, I'll answer from my point of view. No. The implication. Why don't you listen to my answer? Okay, you've had your say. Listen to my answer.
Don't tell me I accused you of anything when I didn't accuse you.
Okay, so what you said was that because I've made money from a rotavirus vaccine, that must in some way have been corrupting, as it is corrupting. Don't talk, I'm talking, okay? So, what did I do? I did a pediatric residency. Well, I'll start from the beginning. When I was 5, I was in a polio ward for about 6 weeks. This was a scarring moment for me, and I think that I don't know if you would know what those things polio wards were like in the 1950s, but they were pretty scary. There was 1 visiting hour a week. You saw children who had were in iron lungs. You saw the people who got hot packs from their Sister Kenny treatments who were screaming. It was literally hell. There was, my mother was unable to visit me. My father couldn't visit me either, and so I sat there for 6 weeks. That's what motivated me to do what I do. What I did was chose to go into pediatrics. I then chose to go into pediatric infectious diseases. I chose to work on rotavirus because rotavirus kills 2,000 children a day. And I was born at a time and doing research at a time when you could do the kind of research to make that kind of vaccine. I then spent 26 years of my professional career working on trying to make a rotavirus vaccine. Once we'd made that vaccine, once we had the strains that we thought could be that vaccine, only pharmaceutical companies have the resources and expertise to make the vaccine. I wasn't going to make it in my lab. If we're going to have a vaccine out there that can save as many as 2,000 lives a day, and this vaccine has virtually eliminated hospitalizations in this country, then only pharmaceutical companies can make it. And pharmaceutical companies don't make it unless the technology is protected. And so you have to patent it. I'm sorry, when we patented it and the company decided to make it, that meant that we made money off the vaccine. It's certainly not why I did it. I mean, it's not what, nobody in their right mind goes into science thinking, God, if I can just figure out which of these 2 surface proteins evoke neutralizing antibodies, I can be rich. Okay, nobody thinks that. You do it because you're just trying to do the right thing for the right reasons, and that's how it ended up. I find it appalling that you would accuse me of anything other than trying to do the right things for the right reason, because you don't know me. If you knew me, you would never say that.
Please sit down, sir. Please sit down.
He's done.
Sit down.
No more.
Sir, if you don't sit down, we're calling the police.